Thanks very much, and thank you for the opportunity to, let's say, talk to this, let's say, wide audience about Sabca as an aerospace company and the capabilities that we have, the market positioning, and so on and so on. But first, maybe I want to show you a very short movie about one of the flights we conducted recently, and then introduce the company, and then afterwards talk a little bit about why we think aerospace standards are important in certain aspects of this industry and how we interpret some of those things. So if we can maybe first show a short movie, and then I will proceed. So what you see here is actually an operation where we do offshore flights, taking off from the Austin airport and then fly overseas, carrying out multiple missions, carrying out multiple tasks. And this is typically the kind of application where high standards are necessary for many reasons. One of them being is that we fly in an airspace which is controlled. We conduct operations from an airport, and then we carry out certain missions. So the risk potential is pretty high, and then risk mitigations are extremely important. That will be part of our presentation. So I want to start a little bit with introducing the company, because again, the subject of today's aerospace standards and aerospace mindset. So let's talk a little bit about Sabca in general. We are an aerospace company, one of the oldest in the world, founded in 1920, more or less together with Sabina. And from that point on, we evolved. At first, we started designing aircraft and building complete aircraft. And then later on, we also introduced, let's say, our space applications. And in 2017, as you can see on the timeline, we had this idea of using our aerospace knowledge, both in the aviation, from the aviation industry and the space industry, to work on, let's say, new ideas to create, let's say, new potential opportunities for our company in the unmanned systems market. So we've been doing that for about 3.5 years now, and up till now is pretty successful. We see huge potential, a lot of opportunities ahead of us. And again, that's the emphasis for our discussion today. We use aerospace standards. Why do we think they're necessary? And so on and so on. It will be covered in this presentation. So in terms of presence, we are part of a larger group, the Blueberry Group, and we have offices, let's say, worldwide, some of them in Europe, and I'll show you the 4 locations we have, the main locations from the Sabca company, but the other ones are more linked to our MRO facilities, so maintenance, repair, and overhaul of both civil and military aircraft in the United States and in Africa. So what you see here are our main facilities, 3 in Belgium and 1 in Morocco. The left-hand side, top left-hand side, is the headquarters next to NATO in Belgium. That's where we have most of the design offices, and our unmanned systems activities, they all take place in the Brussels facility. On the bottom left-hand side, you see our MRO facility in Charleroi at the airport, where we do maintenance, overhaul, upgrades of many military aircraft. Top right-hand side is the Lumen facility. It's basically our composite manufacturing facility. It's been there for about 20 years. And then on the left, at the right-hand side, bottom right-hand side, it is our Morocco facility, where we do assembly of, let's say, low-cost assembly, mostly of metallic structures. So in terms of what we do, we have divided our business into several business units or business lines. The most important one is on the left-hand side. It's more structures and equipment, where the focus is, first of all, on designing and building parts of aircraft and launchers, but also actuators, not just for the space industry, but also for the aviation industry. For example, actuators for flight controls, flaps, slats, ailerons, and so on and so on. The second business unit or business line is the services. So the focus there is on maintenance, repair, and overhaul of aircraft. It's what we call continue their worthiness. On the left-hand side, the first business line is about initial airworthiness. The middle one, services, is continue their worthiness. And the third business line is the solutions business line. This is all about unmanned systems, using our aerospace knowledge to come up with end-to-end solutions. And I will explain a little bit more about our market positioning. What does that mean, providing solutions using unmanned systems? So these are some pictures of the typical components that we both design and manufacture. So, for example, on the left-hand side, you see a complete tail cone of an A330. On the right-hand side, top right-hand side is a horizontal skin of a business jet, composite parts. But I will not go into detail. It's not really the subject of what we do. So let's now focus on the unmanned systems business unit. What is our market positioning? How do we deal with that? And we'll go on from that point on. So if you look at our strategy, what we do is we offer aerospace grade end-to-end solutions for safety critical applications. And we do that for industrial end users, also governmental, but the main focus is on industrial end users. In fact, the end user, they want to have a solution. A solution that means most of the time having data on the table, data that is already processed. In order to get this data, it's not just about having a drone, it's about having a whole ecosystem that is connected together in order to make sure that the end customer has its solution, and that solution needs to be cost effective, and it needs to be, let's say, it needs to be low risk in a sense that the industrial customers, they don't want to be involved in situations where drones pose certain risks to their daily operations. So that's what we do. We basically bring together a lot of, let's say, technologies, a lot of players, a lot of services that are needed to come up with this aerospace grade end-to-end solution. For example, managing a fleet, systems integration, MRO, testing, and so on, all the way up to collecting the data and processing the data using artificial intelligence. So this is for us, let's say, more or less the key aspect. This is how we position ourselves, and that's where the aerospace grade comes in, because aerospace grade means reliable, it means safe, and that is crucial to what we do. So how do we do that? We have two, let's say, ways of working, two models. The first one is build and the other one is run. What does that basically mean? Well, sometimes the market wants solutions that don't exist. In that case, we have to develop it ourselves. That could mean start from scratch, designing from scratch. It could also mean integrating existing components onto existing platforms. That's the integration work. And Sabca, as an aerospace company, of course, has a lot of experience with integration work. On the other hand, there is the run component. What does that mean? It means you use off-the-shelf type of equipment with some modifications, of course, but then you start operating. The customer wants data, process data on the desk. You make sure that with existing tools, unmanned systems, you come up with a solution that works. So it doesn't really involve design. The design was done by someone else, an OEM, for example, but then you do the necessary modifications, you do integration, and you start running that business case. It means you provide or you make sure that the operations can be carried out, the data can be processed, and so on and so on. So what markets do we target today? Our main focus is on three markets. Basically, the first one is natural resources and utilities, the second one being construction infrastructure, and the third one, safety and security. Our main focus today is on, let's say, offshore operations, and there is a good reason for that. I will talk about the offshore, the certification standards and certifiability and so on in a second. But we have to take care of regulations as well, or take into account the fact that regulations today have evolved and they don't allow any type of operation. So our main focus today is on offshore operations for the simple reason that it's within our reach today to do that in a commercial environment. In a few years from now, it's going to be easier also to perform, for example, urban flights. But from a legislation point of view, it's still pretty hard to do that compared to other things. And I think that the aerospace mindset can be useful in a sense that whatever type of mission you carry out, there is always a risk, and having a good mindset or using the right standards will help you to mitigate certain risks as much as possible. And therefore, aerospace standards could be of assistance because they are the highest standards in terms of safety and reliability. So if you look at, market growth, I'm not going to talk about that, but if you look at the different categories that EAS has defined, open, specific, and certified, For a company such as ours, we are aiming at, on the one hand, the specific category, the high risk side, and the certified category on the other side. But as you know, certification is not that obvious. The certification standards are not 100% clear yet. On the other hand, specific category, high risk, is more or less like certification. So there are a lot of questions mark at this stage. It's pretty simple to fly in low risk specific category. It's a lot more difficult to fly in the medium risk category. You could have design verifications and things like that. But still, there are question marks, and it's up to, let's say, the front runners to open doors and to convince the authorities this should be convincing arguments to allow me to fly in certain risky environments. But once you take this step from specific to certified, everything changes, because certification then means type certification, and it means you don't have to go for approvals and authorizations all the time. You have a certified platform, and within the boundaries, the flight limitations of your certified platform, you can basically perform the types of missions you want to do. And this has been an important and a difficult task for us. That is to identify and see how far do we go today in terms of high risk specific operations or certified. Do we have to invest a lot of time in certification? The standards are not clear yet. Can we keep on working in the specific category? That's possible, but of course there is more competition there. And how can we use our aerospace knowledge to make sure that we can push as much as possible to the right, but maybe not all the way to the right now, because of the fact that the standards are not 100% clear and defined yet. So in order to do that, a lot of technologies, a lot of things are needed. And if you look at the start, of course, I've listed some of those. For example, when we started in 2018, really starting to look into technologies, we've done many things since then. And the simplest things are, of course, VLOS operations and C2 link testing and so on and so on. But if you look at the broader technology roadmap over time, there are lots of things that we want to implement. And there are certain areas in which we invest a lot. And as you can see, for example, machine learning, deep learning will become extremely important for us, because apart from the fact that we apply airspace standards, we want to focus as much as possible on future autonomous operations. And in order to go to autonomous operations, we need to make sure that certain things are fully understood. So we need to, let's say, stay in line. We need to understand fully how certain things work. So what you see here is basically our technology roadmap in terms of what it is we have to look into, what types of technologies do we have to integrate in order to make things work. And as you can see, the certifiability and certification efforts, they run through this roadmap, because at any stage in this roadmap, we need to keep on addressing the same question. Are we going for, let's say, high risk specific type of operations, or are we going for certified operations? It does have a huge impact on how you see technology, what kind of technology can be used and what not. A typical example is, for example, CAMO, continued airworthiness maintenance organization. Do you need that? It's like an MRO facility for airlines. I mean, do you need that, or can you just do the maintenance in your garage without adhering or sticking to typical non-aerospace standards? These are crucial questions, and you need to be able to address them as quickly as possible, because they will determine what type of operations you're allowed to do and what type of operations you're not allowed to do. So if you look at this slide, it basically summarizes the typical, let's say, question marks that need to be answered. The first one is detect and avoid. If today we want to conduct high risk operations in controlled airspace, and that's exactly where we want to go to, we need to make sure that we are seen by others and that we see others as well. And there are many technologies for that, but those technologies need to be accepted by the airspace or the aviation community. So detect and avoid plays a crucial role. What kind of technologies are available? That's one question. But the next question is, which of those technologies are reliable enough? And do we have to go all the way to say, well, we need aerospace grade detect and avoid equipment because they're very expensive, they might be pretty power consuming, and so on and so on. But on the other hand, they provide a certain reliability that you need. The same thing is true for command and control. You cannot just rely on one command and control link. You might have to use different links. And the third one, of course, is going all the way to autonomous missions. So that's basically, let's say, the prime and most important question for us. The autonomous missions, is it still, let's say, Is the fact that you want to fly autonomously still in line with saying, I'm an aerospace company that wants to provide aerospace standards? And are aerospace standards capable of making sure that in 5 or 10 years from now, we're capable of performing autonomous missions? It's an important question because if you look at the automotive industry, they also want autonomy for cars. There are different standards in the automotive industry. They could also use aerospace standards. Shall we borrow from the automotive industry? Will we provide aerospace standards to the automotive industry? It can work in two ways, but one thing is certain: aerospace standards provide higher safety guarantees than automotive standards. Which one should we apply or not? These are the typical types of questions that we ask ourselves, and they're crucial for our survival. And it explains how we position ourselves, let's say, within the US ecosystem. I think that more or less concludes what I wanted to explain today, because I see my time has run out.